Welcome back to GKE Essentials. My name is Anthony Bouchon. We've already covered what you should consider if you're a central platform team looking to build a large-scale GKE cluster. Today, we'll talk about what you might consider if you're a central platform team who wants individual service owners to move fast with their own smaller-scale GKE clusters. Let's get right to it. There are probably a dozen jokes out there about standards in our industry, namely about how many there are, but I promise you in this scenario, they're really important. You see, even if you don't own each GKE cluster individually, you want to make sure that users start with a cluster setup that you as a central team can recommend. If we don't, well, we could end up with local optimum traps, or even worse, clusters that are not up to par with the standards of your organization. You can think of defining these standards across two dimensions. One, configuration specific to GKE clusters. This means the setup of the underlying cloud infrastructure and GKE features that the cluster might enable. And two, Kubernetes resources you want in every cluster. These could be network policies, cluster roles, or other resources provisioned using the Kubernetes API. Both are important if we want to give teams power to move independently and safely. So let's introduce a few ways in which GKE users can achieve this today, starting with GKE cluster configuration. Now, we can't discuss standardizing cloud resources without talking about Terraform, one of the most popular open source tools that lets you write common configuration across infrastructure providers. And while you could use Terraform to provision individual resources with every configurable option imaginable, Terraform also provides users the ability to create modules. Modules are a great way to group resources. In GKE's example, you might group a cluster resource, a few node pool resources, and a service account resource. Modules are also a way to provide opinionated infrastructure, using Terraform's ability to provide fixed values to implement your organization's best practices. Like, for example, you could ensure that GKE clusters have network policy enabled. While authoring your own modules can help you codify your organization's best practices for security or performance, you can also find modules provided by Google for your use or reference in the description below. Alternatively, if you are deeply invested in tooling from the Kubernetes ecosystem, you can also evaluate defining your GKE clusters using something called Config Connector. Using Kubernetes custom resources and controllers built by Google, you can use Config Connector to write your cloud infrastructure, including your GKE clusters, using the Kubernetes API. This allows you to use tooling like Kustomize and Kept to templatize and package your manifest defining your infrastructure in the same way you might for workload definitions in Kubernetes. Finally, whereas you may run the Terraform CLI packaged in steps of a pipeline or some automation tool, Config Connector is run via Kubernetes controllers. This means that they're constantly driving resource current state to your desired state. This adds in an element of diff reconciliation, which can help prevent drift or unwanted changes made manually to your set of GKE clusters. And if you want those controllers for Config Connector managed for you by Google, you can check out a service called Config Controller. All right, so if we use either of the aforementioned tools right, we should have our GKE clusters provisioned. Now what? Now, we might want to provision common Kubernetes resources to these clusters that teams create. Google's Config Sync helps you achieve this via a pattern called GitOps. In short, meaning that we are using Git as a source of truth from which multiple clusters can pull Kubernetes manifests. With Config Sync, each cluster will have a local component that pulls manifests from a Git repository and applies them as Kubernetes resources to their respective cluster. Like Config Connector, Config Sync performs diff reconciliation, but for these Kubernetes resources that belong in each GKE cluster. This means that each cluster-side component of Config Sync is constantly ensuring that resources in the Git repo match what exists in the cluster. So if you want consistent cluster roles, storage classes, daemon sets, or network policies, you can use Config Sync to make sure they'll always be present in your GKE clusters. Now there's a lot in this space, but hopefully this gives you the lay of the land and a place to start. There are a few next steps if you're just getting started on this journey that I might recommend. For example, you can evaluate how you can enforce that cluster configurations and Kubernetes resources adhere to policies that you define using projects like Open Policy Agent. You can also examine if you could benefit from more granular control with config sync by having subsets of clusters pull subsets of resources that match their cluster's profile. But perhaps most important is to now look at these tools and principles in the context of your team, your people, and your organization, so that it makes sense with what works for y'all. Check out the links in the description below to learn more, and as always, thank you for your time.